Alright, there are two different ways that you might see empirical formula problems. One way is that you might be given a percent composition of something, or another way is that you might be told how many grams are present. Here's an example problem. Quantitative analysis shows that a compound contains 32.8% sodium, 22.65% sulfur, and 44.99% oxygen. Determine the empirical formula. Now, notice that this one is giving you percentages. I'm going to start out by making this chart. One heading is called elements, and this is the number of elements. The MM stands for the molar mass. We get this from the periodic table. And this is how many grams that we have of this particular element. This is how many moles we have of that particular element. This is the percentage of that particular element. Now, they don't have to exactly be in this order. Anytime we're working with a percentage, always assume that you have 100 grams, because that's an easy number to work with because percentages are in hundreds. So if you have 32.28%, well, if you had 100 grams total, you would have 32.38 grams of sodium. If you had 100 grams total and you had 22.65% sulfur, you would have 22.65 grams sulfur. If we had 100 grams total, you would have 44.99% oxygen. That means you would have 44.99 grams oxygen. Now, we're going to convert from grams to moles, because we're going to need to know that when we write our formula. The formula is not written in a ratio of grams of one element to another, but it is written in ratios of moles of one element to another. So all I did down here was I converted the number of grams we have to the number of moles. So I divided what we started with by the molar mass. So as you can see, we had 32.38 grams of sodium. I divided it by the molar mass. That means I have 1.409 moles of sodium. I have 22.65 grams of sulfur. I divided it by the molar mass. So I have 0.706 moles of sulfur. I had 44.99 grams of oxygen. The molar mass is 15.999 grams per mole. So I divided 44.99 by 15.99, and I have 2.812 moles of oxygen. Now the second step, after I filled out my chart, is I'm going to write out my elements in order. In this case, since we've got a sodium, we have an ionic bond. Our cation is going to go first. We have to use a little bit of common sense here. If we have an S and an O, we probably have something like sulfate, sulfite. It could be persulfate or hyposulfite. So I'm going to write out my N first, your Na, that is your cation, my Na for sodium. And then I'm probably dealing with some kind of a sulfate, sulfite, so I'm going to write my S and my O. Notice that I'm going to take the number of moles and I'm going to write it down here right next to, as a subscript, each element. 0.706, and here's 2.812 moles. So I've rewritten what I had on the other page right here. Now to find, according to the law of multiple proportions, these have to be whole number ratios. So to find our whole number ratios, step 3 is we're going to divide by the smallest number. In this case, my smallest number is 0.706. So if I divide 1.409 by 0.706, I get a number 1.995, which is very, very, very close to 2. 0.706 divided by 0.706 gives me 1. 2.812 divided by 0.706 is going to give me a number very, very, very close to 4. So the empirical formula is Na2SO4, or sodium sulfate.